miserable childhood that you had in Limerick, this so-called miserable childhood that you've peddled your lies all over the world, right? Miserable lanes of Limerick, miserable childhood, miserable people of Limerick, misery, 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 the whole flipping way. If that's the case, why did you not discuss your well-paid employment with Jackie Brosnan? Why did you not discuss your years with St. Joseph's Spy Scout movement? You never discussed it.
Okay, for the same reason
St.
I
Joseph's
didn't
Spy
discuss
Scout was the elite
various
Spy
schools.
Scout movement.
You've had
of
enough
Limerick.
time now.
Elite
Hang on,
Spy
Jerry,
Scout
Jerry,
movement.
can I just
You
ask you-
are a liar.
Okay, you've made your point.
You're a liar.
Jerry, can I ask you one question? And I think it's the reason Frank was asking how old you were, is that he's writing of a time from before you were born.
Frank, Pat,
I mean, isn't that so?
You're a journalist, you've heard of research. I have interviewed over 70 people that are contemporaries of Frank McCourt. I interviewed Moira Gallagher. She describes Angela McCourt as the angel of the lanes.
Can I also
Angela
suggest to you
McCourt.
that the late Jim Kemmy thought that Frank's book
Jim
was
Kemmy
an accurate description of the way things were
Jim
in the
Kemmy.
Limerick of their mutual youth?
Jim Kemmy, with all due respect to him, was a very close friend of Frank McCourt.
No, he
Always
wasn't.
has
I
been.
didn't meet
Yes,
him
he
till
was.
just before he...
Teresa Carmody was 3 days away from her death. When you wrote in your book that you had sexual... Oh. The hell is that? That you had sexual intercourse with her. Nowhere in your book did you say it was with her consent. Was it with her consent, Frank? Was it? Hi, guys. Hi, Simo. Tiny taxed tofu. Yes, so I finished. I had to do a few of my taxes. It was okay. Got it all done. So sorry for the delay in stream, but chores had to be done today. Today was a chores day. Living life can be a chore sometimes, as they say. I don't know if they say that, but I'm saying that anyway. Harry, hello. Star, Max, Pavla, welcome in, Evandriel, good to see you. Daniel, Lind. Hope I said hello to Harry already. Pook, welcome in. Happy Sunday. Happy last stream of March. It is over. It's game over, man. Game over. So yeah, it is officially March, which means this is the last day. Well, sorry, it's not last day of March. This will be my last March stream. Despite losing a week and a half of, doing stuff, I still streamed 8 times this month. So you know what? I know that sounds really little from many people. But for me, that is average. But I'm just happy we achieved that. Yeah. And from here on in, obviously in the next 2 weeks, it'll be a bit chaotic. But after that, my schedule should be freeing up more and more and more. Hi, Neophyte. So today, I actually want to revise some logic gates, if that's okay with you guys. So I have some breadboards. So we're actually going to do circuit analysis ourselves. We're going to revise some Boolean stuff. It's been half a year since I've done this stuff. So I'm just going to do a quick revision today because I want to build stuff. So I want to revise a little bit. Now, theory will only get you so far. I want to do some theory and then I want to prove it using real logic gates as well. Hi, Silver, Rogue, Conrad, welcome in. Rookie numbers. Sure is story of my life. Story of my life. Hi, Cyborg, welcome in. Like I said, I proposed a front page thing for, I think, like the 7th of April or something, during my honeymoon. I keep mentioning this because I'm crazy. Why am I doing this? But I proposed to do 8 hours of crash course logic gates on the front page of Twitch so that by the end of the lesson, after 8 hours of studying hardcore logic gates, transistors, and Boolean algebra, I will show how these little bastards... These tiny little things. They're not even actually that tiny. The real ones inside your computer are even tinier. Let me show you. These tiny little SOBs right here. Store memory. What does memory mean? So that's the goal of my application for the front page. And you know what? Even if it doesn't happen, I plan to do a special stream on that topic anyway. I really want to show a fun video or teach a fun lesson topic on that. That'll be good crack, I would say. Star, 405 streams. That's crazy. That's crazy. Welcome in, welcome in. Integrated Circus, I sees, exactly. My day, Star. That number is very, very small though, Star. If only I had streamed more. If only I was a full-time streamer and streaming 5 days a week. If only. I'm letting you down, really, if you think about it. Good coffee. Coffee. Yeah, I hope so. I hope so. So today's lesson is going to be exactly that. We're just going to do a bit of revision on those. Do I have a textbook on electronic devices? I do, but it's at work. That's what I teach. Yeah. Schmuck. Okay. It's okay. It's okay. Yeah, Jack Shadow, I hope you'll enjoy it. I uploaded it today because it was supposed to be uploaded weeks ago and I didn't notice, but apparently there was an error in the upload, so had to upload it today. But yeah, I hope you enjoy. I'm glad to hear that though. Like, I'm glad to hear that me uploading my playthroughs is catering for a very, very small group of people in the sense that it is catering for some people. Like, oh my god, I found this person and she played this one game that I love. I want to see how she played it and what her playthrough is like. I really like that's exactly what the archive is there for. So I'm really glad to hear it's making its use. What does memory mean? I don't remember. Hi Hacks, hi Zier07. Welcome in. How are you guys keeping today? Are you ready with your ban hammers? Ready to ban anyone and everyone? I'm a little bit tired today. I hope I'll stream at least until 7. But I've been waking up earlier and earlier. I've been waking up with sunrise. I don't know what's going on. Maybe it's just the summer vibes are hitting, but I've been getting up every sunrise. I think the reason I'm getting up is because of Bambi. So about 2 months ago, we started letting Bambi sleep in our bedroom because she was lovely. She really missed us one day. We left her alone for a day. When we came back, she just wouldn't leave our side. So we let her sleep in the bedroom and she was really good. So we decided, you know what, let her sleep in the bedroom. So she's kind of like herd mentality. She wants to stay with us in the same room to ensure safety and numbers and all that. But what's happening now is at the crack of dawn, she gets the zoomies. So the zoomies include downstairs to the hallway, up the stairs, through the hallway, into our bedroom, and underneath the bed. And underneath the bed is a bunch of boxes, and she jumps into the boxes and crashes into them, and, you know, she has great fun there. But you can imagine that it's a huge ruckus. And so every morning it's been coming earlier and earlier and earlier and earlier and earlier. So today I woke up at 5:45. I don't think it was sunrise yet though. But still, it's getting worse. Summer's gonna be rough. You have a pet deer. I have a pet bunny. And they shouldn't be alone for this reason, I think. But yeah, unfortunately, my Bambi is a troubled young ball of fluff. So yeah. I try to be mindful of that. Like, even though I want to advertise, you know, don't shop, adopt kind of thing, I also don't want to advertise that people should have bunnies solo. Because in a way, we did give up on her a bit. Or it's the opposite. People kept giving up on her and we didn't. Me and my fiance to be up petting around 5 a.m. Oh, she's so demanding. Fuck! Clocks go forward next weekend? Wait. Shit. Son of a bitch. Shit. I'm losing a weekend, an hour. I'm losing an hour. On my holiday. I'm pissed off now. The language. Listen. Are you new to the stream? Scam. I know. I know. Really, it is a scam that we lose that 1 hour on a Sunday when it is a weekend and a holiday. They make us lose 1 hour on our days off. Conspiracy theory? I think not. It can't be a conspiracy theory. Oh, thanks for pointing it out, though. Yeah, it'd be interesting. Like, I actually don't. Okay, no, I don't know if this works. But time is arbitrary. There can be a universal time where the whole universe agrees that this is 8 o'clock, okay? But for you, 8 a.m. or like 0800 hours, and you look out the window, it's pitch dark and it's time for sleepies. Would be an interesting kind of setup, but yeah, it's just a thought. It'll work. I already see the flaws in my plan to take over the world and implement the strategy. I just shut up, Chad. Just shut up. Yeah, a lot of countries don't, Rogue. I know Russia doesn't, because I used to have to keep track of that to call my granny every summer versus winter. 3 hours behind, 2 hours behind, 3 hours behind, 2 hours behind. Dr. Ambassador, fellow nerds. Hello, Jay. How are you today? Welcome in, welcome in. Hi, Fun Dragon. Floatware, I hope you guys are keeping well. Hi, Phantom. Oh, China only has one time zone. Whoa, that is crazy. Because China's massive. Yeah, I think there's 9 time zones in Russia. Is it 9? How many time zones are there in Russia? One, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. All the way from Kamchatka to Kaliningrad. Oh yeah, it is a made-up thing. True. But if it's a made-up concept, it's a made-up concept where society forces us to work 9 to 5, you know? Oh god, I sound like those people on Manosphere. That documentary inside the Manosphere. 9 to 5 was implemented so they can control the masses. You're part of the hive mind or something. If you're working 9 to 5, you're a beta and you don't think for yourself. And something. Ooh, grunt. Hopefully that was good enough cosplay of one of the guys on the Manosphere stuff. I'm still waiting for the EU to finalize dumping the time. I would hope they would. Yeah. The concept doesn't make sense. What's really interesting is if we want to stick to the original time, then we'd actually be on the winter time. But a lot of people wouldn't be happy with that. Everyone would rather be the summertime, the one that we're going to change to. So I get that. Doesn't that make me an Omega? Phantom, listen, I don't know what that makes you. Yeah. Zir, by the way, I missed it. 285 stream streak. Let's go. Yeah, if anyone doesn't know what I'm talking about, it's about that documentary Inside the Manosphere. It was quite good. I do know those guys. Some of them started off on Twitch, so I do know of them. They all got banned though. I know they're only streaming on Kick now, if I'm not mistaken. I know some people say you have to feel sorry for them, but I don't. I don't feel sorry for these guys because I think those people who push these scams and the lies are manipulating, and they know it doesn't work. They know it doesn't work. I think they're in on it. They know those kind of things don't work, and they're just influencing very young, impressionable boys and ruining their lives. Does that make sense? I feel bad for the boys who get influenced by this and who invest their money in their courses and in their online investment things. I'm not sure what it is exactly, but all the scams that they push forward. I feel sorry for those guys. I don't feel sorry for the guys who are pushing it, because I know that we know what they're doing. They're doing it for clout, for money. That's my summary of it. I feel, yeah. What does shills mean, Sunbeam? Hello, by the way. Boys do need better role models. I wonder. I'm trying to think of who do I kind of look up to. I don't look up to many people anymore. I used to look up to some people, but then I had a bit of a... I think we all experienced that at one point or another, maybe. Do you know that figure of speech of don't meet your heroes? I had that moment happen to me. And so I don't look up to anyone anymore. I'm grateful and I look at what people do and I try to take advice and things like that, but I don't think I have role models anymore. I'm like, oh, that didn't go. It is important to realize that, though, that the people you look up to and the role models and all of that are just humans. They have bad days and they have good days, and we can all be shitty. Fuck role models. Each kid, everyone has positives, negative. No one is perfect. Exactly. Oh well, that was a bit of a side rant, but yeah, be careful about role models. It's okay to look up to people and stuff, but yeah, just don't put them on a pedestal. And never meet your heroes. That's my life lesson there. Oh. Happy 125 stream streak. Let's go. Excuse me, I'm burping. Are you doing any research right now? Yes, I have a master's student and a fourth year student at the moment. And both of the students are working on thermodynamic potential measurements of vanadium flow batteries. So that's my research at the moment. And I'm writing 2 papers on it. I've been writing them for a year. Oh, I'll get it done this summer. She said last summer, but I'll get it done this summer. At least the first one. Yeah. I will put my first paper for review by the end of the summer. It will go towards review. Don't clip this and then bring it up to me in August, Deckers. We'll hold you to that. No, scams, you can... I feel bad, but I've been scammed a few times as well, to be honest. You live and learn. Some things are more obvious than others. Some scams can be very, very good. I got scammed live on stream. The IQ test. That was a scam. Thank you, Phantom. Thank you. Ooh, nice. And last year I got scammed with Unpust, our postal service. That still pisses me off, by the way, because I reported it to An Post and said, do you know that there's people, you know, scams? And they said, oh, you should check our website. We tell everyone that we never send anyone a message. An Post, every time there's a package, you send me a message saying there's a package and you say, press this link to tell us what to do with the package. And every week I have to say to leave it on the porch or something like that, or leave it with my neighbor if I'm not there. You're lying to me, An Post. You're lying to me. You're lying to the nation. Anyways, I needed to vent. Oh, Shill's definition. A few comments up, but I think it covers it. Yes, let me click into your name and I'll see your message. What does it say? Oh, someone else. Does someone else say it? Let me check. Can you copy and paste the message? I'm so sorry. I can't see it anywhere. What does Shills mean? A shill, also called a plant or a stooge, is a person who publicly helps or gives credibility to a person or an organization. Is it negative, though? Is that a negative term? So am I a shill for, like, this was a sponsored jumper before. So am I a shill for advertising this website publicly? Am I a shill? Or shill specifically negative? We say glazer. I don't actually get that. I hear kids say it all the time. Urban Dictionary. Okay, Urban Dictionary doesn't come up in. So glazing, yes. Okay, no, that's not right. I don't know what that is. I'm very confused by all this language. Phantom will appoint you my educator. You will teach me how to how to Gen Z speak. And you only have like a good few years left, because in a couple of years I have the next, is it Gen Alpha next? Are iPad babies and Gen Alpha the same? Glazing is not as negative as shill. It's basically you talking about Faraday. Oh. Yeah, no, so glazing is like singing praises of someone. Often they do not tell they're associated. Ah, okay. Hi, Mom Farmer. In how many years am I going to be teaching the iPad babies? iPad babies years. Generation Alpha is from 2010 onwards. It is 2026. Oh! I'm teaching them next year. The iPad babies are coming. The next year's students going to be the first. Damn. Oh, I'm old. Is it possible that they may... Not really. Because of our education system in Ireland, it's very rare that we have young kids going into university nowadays. We we used to, like, when I was going in college, it was pretty normal to be 17 going into college. But nowadays, with the almost all secondary schools have mandatory transition year in placement now, which means that even if you go to school a little bit young, you will be 17, 18 going into college. Oh no, but if there was a child prodigy, they would go to, I don't know, Oxford, or the most prestigious school in Ireland is UCD. No, not UCD, Jesus. Trinity College, for example. So they'd go to Trinity, or they'd go somewhere abroad. No. The kids wouldn't be. We don't really get them. Hey, Cheska, welcome in. Yeah, so I technically graduated secondary school at 16, but entered university at 17 just because of my birthday being in August. So that was unusual. I would have been one of the youngest people going in. Or is it? No, I got it wrong. But that is what it used to be. It's very rare now. Anyways, that was a bit of a rant and two, as it always is, but we're half an hour into the stream. I think it's time to open up our notebooks and copies. Hope you're ready to study with me today. So what we're going to do is we're just going to revise some logic gates really, really quickly. I actually have my laptop with me. I have lecture notes on this. Why not? I have my own lecture notes on the topic. Hi everyone, welcome in. I'm just gonna boot up my PC real quick. Nobody look at my password. Go away. Shoo! 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 Take off your glasses. Too late now. Too late now. Let me boot up my laptop. Update lecture notes. Let's take physics. Thank you, Orange Path, for the 420. Really appreciate it. Thank you. Haven't heard that sound alert in ages. Thank you so much. Hi, Mord. Welcome in. Welcome in. Okay, no. Stop getting distracted. Chat, focus. MOSFETs. Introduction to digital. Transistors as logic gates. Noise immunity. In algebra. Is it Boolean algebra? Where do I put in the logic gates? I guess it's when I teach them Boolean. T1 7400 series. What's that? Is that your password? Yes. Thank you so much for the 69 biddies.
Looks like meat's back on the menu, boys.
Are we testing all the sound alerts? Thank you, Orange, for all the bits. Really appreciate it. You're very, very kind to do so. I don't know where I teach logic gates first. Weird. Oh well. They were just left in there, were they? Were they? Hi, Ronan. Welcome in. Welcome in. So I'm just going to leave my laptop up here just to reference a few notes. What we're going to do is we're going to revise some logic gates. We're not going to talk about how they're built and how they operate. We're going to go straight into their truth tables just for a bit of revision. And then we're going to test some combinations, like putting things together and seeing if it's true. So that's hopefully the goal of today's little lesson. That is very, very loud. Thank you so much, Blitz, for the Blitzy even. Sorry for the 200 Bitsy. Oh my god. Just ignore me. Just ignore me. That was loud. It was. It was. From France. Hello from France. Welcome in, Ronan. Blitz or Blitzy is fine. Fair enough, fair enough. I didn't want to misidentify anyone. Let me pick you up, chat, while we write some stuff on the board. Actually, before I do that, who wants a bit of thermodynamics before we start logic gates? Anyone interested in learning a bit of thermodynamics? Do we want to know about the heat engine? Always.
Looks like meat back on the menu, boys.
Oh, Farmer, thank you so much for 169 bits. Really appreciate it. And thank you so much for the enlarge emotes. Really, Labrats, thank you so much for starting a rare community train.
Looks like meat's back on the menu, boys.
What is this new hype train again? I am so behind the times. Reach level 2 to gift emotes to some lucky viewers. Oh, so the whole community gets emotes, even if they don't participate, if we reach level 2. Okay. That's new to me. Has that been there for ages? Am I just slow? Maybe I am. It'll explain a lot of my life. I've never seen this type. Okay, I'm not the only one, so great.
Looks like
Meat's back on the menu, boys.
Looks like meat's back on the
I'll
menu,
bite.
boys.
Pushing this train.
Pushing this train. Thank you, Orange Pat, for another 500 bits. You've given so much. And thank you, Silver. You guys are amazing. Thank you, Small Bread. Teach us how to build a hydrogen bomb. I'm going to say nah. Oh my god, that is such a scam train. It's at 99%. Okay, that's a real scam train.
Looks like
Meat's back on the menu, boys. Choo-choo! All aboard the community scam train! Thank you, Harry, for gifting 100 biddies. So what do we get now? You've unlocked 2 emotes for chat. Keep leveling up to give away even more emotes. What are we giving away, though? I'm so confused. This is so bizarre.
And they call it a mine.
A mine! Spooky, thank you so much for tier 3. 22 months. Let's frickin' go. Thank you. You're very, very kind. 5 emotes for the chat. Oh, cool. You kicked it off to level 3 as well, Spooky. Jeez. Okay, well look, today we learned we're doing a community train. Be wary, it is a scam train, so don't feel pressured to bit and to give subs. But if you do, we're all getting emotes, I guess. Not too sure still about this. Dino, thank you so much for a sub. Appreciate it. Thank you. You're very, very kind. Clearly, nobody wants to learn about the efficiency of an engine. A mine! Thank you so much. Thank you.
And they call it a mine.
A mine! Fishman, thank you so much for gifting a sub. Now, I got subified. Yes, you came in, you followed, and you got a sub against your will. You are now a lab rat of this community, which means that you are going to be involved in experimentations, again, against your will. Currently 5 random people. And what emotes do they get? Do they get my emotes or chat Twitch emotes? Can I get my sample hydrogen bomb? I'm never going to explain the efficiency of an engine. Because I can't leave a stream in the middle of a hype train and I can't teach in the middle of a hype train, surely. That has to be the rules. Tofu can't teach during a hype train and Tofu can't leave if a hype train is active. Those are the rules. What type of engines? This is a heat engine. An engine that does work, assuming that heat is put into it. So what I want to show you is 2 important concepts. Maybe you've heard the figure of speech of you can't win. And number 2, you can't even break even. And I want to be able to explain what that is. A hype train engine. Exactly, a hype train engine. So what we have is, if you like my drawing of my wonderful cog, careful, I said that word very, very carefully, where we have a hot reservoir and a cold reservoir. In physics, when we say something is a reservoir, it means it's so big that no matter what you do to it, it'll stay the same temperature. So a hot reservoir remains hot no matter how much heat we take out of it, and a cold reservoir will stay cold no matter how cold it is. That's kind of the idea behind this. And obviously we have a cog in the middle for the system engine, and we have heat flowing always from hot to cold. So that's the diagram we have. We have hot heat coming in, choo choo, all aboard the scam train, and then the train can split into 2 paths. Some goes into the cold reservoir because that's in the direction it wants to go, and some goes into the work being done, the useful thing that we want in our system. So what we're trying to do is, if you know the first law of thermodynamics, energy cannot be created or destroyed, but can only change from one form to another. There's different versions of the first law. Basically, what we're trying to show is mathematically, or at least conceptually, that we can never produce more than 100% out of an engine. That's part 1 anyway. Part 2 then, turns out it's even worse. It's even a worse scenario. It sounds like something from poker. Yes, exactly. So it's not going to be poker exactly that I'm going to reference. I'm going to reference investments, money investments. Good coffee. Good coffee. It's my 3rd cup of coffee today. We're going to not drink coffee anymore today for sure. Is this why fusion is so difficult? The amount of energy with our technology at the moment is that we put more energy into create it than we get out of it, yes. And if I'm not mistaken, it was a misleading article to say that we created net positive energy in the end. Bob Farmer, thank you so much for 200 biddies. Really appreciate it. Because they didn't talk about the full cycle. Full cycle is still not net positive at the moment. 3, 2, 1. Hype train complete. Choo choo. We're leaving the station. We had a 95% complete level 3 hype train. Your community contributed 3 sub-gifts, 1,899 biddies. I hope whoever got the emotes spams them to their delight. Oh, Menchie, did you get an emote as well, class? Okay. So I've described to everyone the heat engine. When we talk about efficiency, as in how efficient our battery is, how efficient, anything in our houses, what we tend to say is, what is the useful stuff that we want for our thing to do, and divided by the amount of work that we're actually putting in. So in that case is like, let's say you take your refrigerator and it takes 200 watts to operate it, but only about 100 of those watts is actually being used for the fridge stuff. There's also being heat produced and that needs to be dissipated, and there's all these other little things that energy is being wasted on. And so the efficiency would be 50% then. So a cat is like 0% efficient. Well, by that definition, my bunny is as well, yes. So in this case, our efficiency would be the work that we're doing in our engine, the useful thing, divided by QH, the heat that we are putting into the whole system, which is this guy. As you can see, I've drawn it carefully, where this is all the heat going in, and whatever portion of that is, of that heat, is split into this direction or this direction. Because remember, heat is just energy. It's energy in transit. Now, the first law of thermodynamics states that the total energy in the system, this thing here, or the total change in energy in the system, QH, must be equal to QC plus W, the work done. So QH is equal to QC plus W. Rearrange the equation to get W on its own. That's QH minus QC. We sub it in back here, QH minus QC all over QH. That's just 1 minus QC over QH. Very interesting phenomenon has just been discovered in this live moment. The 1 represents 100% efficiency minus QC over QH. So this is a fraction. And obviously QC has to be smaller than QH, okay? Or, question mark, the exact same. So our engine can only be 100% efficient if QC is equal to 0. Efficiency can never be greater than 1. We can never get anything higher than 100% efficiency. Number 1, you can't win. So when we talk about investment banking, or I don't know, I'm clearly not an economics person, but when we talk about investment, you put $1,000 in, but then you get, you know, $100 back every month or something. You bear with me. Eventually, you will make more than the $1,000 that you put in. But what this says is if you put $1,000 into your investment, you will never get more than $1,000 back. $1,000 is the maximum that you will ever be able to get. Oh, no hacks. And it's too hot to put it in, right? Now, part 2 is interesting. Part 2 is when we need to talk about entropy. So the second law says that entropy can only increase. So in our closed system, it can only increase. I'm calling you as an expert witness when my employer demands 110%. You can tell him to, or them, sorry. You can tell them to fuck right off, because that is BS. Anyways, where was I? Second law, entropy can only increase. What is entropy, chat? So it's a bit weird concept, entropy. Some people say it's chaos. Some people say it's disorder. I do like the term of disorder. But this is one of the proper first classical definitions of entropy, and it's really, really important. I think this equation is important. Let's look at this one. Delta S, the change in entropy, is equal to the heat provided to whatever system we're talking about, divided by T. Not delta T, T, at a temperature. Okay, so let's grab a box. I wish, but I'm not sponsored by Bamboo Lab. Let's grab a box. Dispersion 2, exactly. That's another way. This might actually, that definition might be very good here. Oh, it's gold. It's gold filament. So let's pretend I have a box and I have gas particles in there, balls, moving all the way around, right? Shilling again. No, but I'm not actually sponsored by Bamboo. I wish. There's balls moving around, okay? And let's say it's super, super cold, like 10 degrees Kelvin. The balls are moving, but they're so slow. Okay? And let's say I put 100 joules of heat energy into the system. It's going to be an immense amount of heat system for all those balls inside the box. They're going to get so much energy. They're going to go all over the place. There's a lot more chaos going on, a lot more disorder because they can be distributed and bounce off a lot more surfaces. So you've increased the entropy of the system significantly when the temperature is really, really low. However, what if I did the same thing when this box is really, really hot? Let's say it's at Kelvin 300. And the balls are bouncing off like crazy. Woo! Having a party. They're bouncing like crazy and crazy. And then you add 100 joules of heat into that system. Those balls are like high as a kite already. 100 joules of energy is not going to do a whole lot. So when your temperature is at a really, really high temperature already, adding the same amount of Q in there is very negligible. So your delta S is going to be very, very small. The amount of energy that you've added to your system does not contribute much to disorder. While at lower temperatures, it's a huge contribution to disorder. I don't know if that makes sense. I don't know if I've made things worse for you in your life by my explanation, but I like to explain these things with my own analogies, my own thought processes on this topic. Lurk away, wrong town. Welcome in, welcome in. So, there's two equations I have here. One for delta S, and that's delta S again, is equal to a reversible reaction, so path independent, whereas a path dependent depends which way you think of it. But in this case, it is the inequality. Got to do back to Clausius inequality. Delta S is larger than or equal to Q over T. This means that entropy cannot be destroyed. I know this sounds a bit weird, but anytime you have a system, especially when we're talking about heat in this case, anytime there's heat in a system, you're creating disorder. You're creating entropy. It's unavoidable. You either A, create it, or you're handed entropy and you have to fucking deal with it. It's just like, it's when life gives you lemons. What can you do? They're given to you. You have to deal with them. So that's exactly the problem with entropy in our system. We can either keep it the same, but we still need to keep getting rid of it every single moment, or we're creating more and more of it, which is fine. I'll take the blame for the heat. Welcome inside, Bish. Ultimately, what we're trying to say is that the entropy out of our engine has to be equal to, at the very least, the entropy we've put into the system. More than likely, though, because no reaction is perfect, it's going to be larger than. But, argument's sake, let's say we take the most perfect ideal scenario in the whole universe. So that's where we get the inequality. So entropy out must be larger than or equal to the entropy in. We have an equation for entropy. It's Q over T. So QC over TC, the entropy out must be larger than or equal to the entropy in QH over TH. Are we on board? Can anyone please ask a question if you're really struggling with what I've said thus far? We're not, that's slightly different, Taffy. There's different levels of entropy that we can talk about. We're starting with Carnot 1. This is the heat engine. Nothing we're saying is incorrect here, but it's the model that we're working with at the moment. Just not today. I do love talking about the heat death of the universe. How many lemons did life give us? Way too much, Ilgaz. Way too fecking much. That's how many lemons we got. Okay, so let's rearrange the equation. QC over QH over TC over TH. Remember, this is the efficiency from the first equation, from the first board that I showed you. We can sub in for the temperatures, because you can't really measure heat energy. Maybe you can, but it's kind of tough. Temperature is way, way easier to interpret. So we can sub it in here, which means that the efficiency is less than or equal to 1 minus TC over TH. Can't be 100% efficient unless TC is 0 or TH is infinite. Basically, if we want an 100% efficient energy, it needs to be 1 minus 0. This needs to be 0. How do we make this fraction 0? Tc has to be 0 or Th has to be infinite. Both cannot be true. So that's where this term comes in. You can't even break even. You can't even achieve a 100% efficient energy. You will lose it in some shape, way, or form, always. Zero Kelvin, exactly. If you subtract 274 degrees of heat. So, that's the thing. So some might point out, well, what if you have 0 temperature? The third law states that that's pretty much not possible. So sometimes the third part to this figure of speech, number 1, you can't win. And number 2, you can't even break even. The third part says, based on third law, you can't leave the table. I think that's what it says. Someone can Google it to make sure that I'm not lying. But I think the third law of this kind of thing says that you can't even leave the table, that you have to play the game. How efficient is nuclear fission? I think it's like 30% efficient, 32 maybe. The last time I checked, it's an efficient system. All round efficiency is 33%. We can't leave the table, but can we flip the table? Thank you, Cookie. You have to play the game until you lose. Exactly, Orange Path. There we go. You have to play the game. I mean, honestly, if an engine could turn 1 kilowatt of chemical energy to 500 watts, I'll call it inefficient. You'd be surprised, but that's actually not bad at all. So yeah, nuclear fission is about 33% efficient. Like nuclear power plants, they're about 33%, and they're one of the good ones. You'd be surprised. Oh, sorry, I misread that, Ilgaz. I'll call it infinitely efficient. There we go. I didn't read the second part properly. Exactly, Max. Lots of chaos happening. There is lots of chaos. A lot of disorder with the lab rats today. But entropy is really, really cool. I want to do a full YouTube video on entropy, and I want to do all entropy. So I start with this stuff, go on to Clausius and inequality, move on to a few other ideas, and then also build on Stefan Boltzmann and apply it to a few really cool things in statistical physics. I want to cover all possible implications and definitions of entropy, but I started looking into, like, that would be a really long YouTube video. Maybe I'll make it a series. I'm not sure. It's a lot of hard work. The stuff that I do, I need to plan ahead. You have to be very, very pedantic about these kind of things, or I need to be anyway. It's quite shocking the amount of people who, like, for 1 minute, let's say I post a short explaining how an engine works, and there's all these conditions that it has to be quasi-static and the temperature has to be equal and all of these conditions. But if I keep saying those things, like all the asterisks on every topic, I'll never get to the short, right? I'll never be able to explain it. So in the short, I have to remove all of these things, add what I can in captions, and always say, just if you're misunderstanding, look at the full YouTube video where I do explain all those things more thoroughly. But the amount of bombardment I get from people always correcting me is like, you don't know what you're talking about because you did not mention A, or you're totally wrong because you did not mention C, and so on and so forth and so on. Anyways. Hi, Kim. Welcome in. We were just talking about entropy. My point is, there's so many different conditions for thermodynamics. Thermodynamics is a very complex module. Exactly. It's actually. How was your stream yesterday, Kim? We stayed a little while. It was definitely interesting. There was talk about stuff that I don't know if I can repeat. If you guys are interested, Kim, we raided into Kim yesterday, and they're a VTuber here on Twitch, and they're doing masters in astrophysics. So if you're into space and nerdology and God knows what else in between, make sure to check out their channel. Entropy is chaos is inevitable. Basically, young at heart. Yeah. Yeah. Oh, don't worry, Kim. No, it's fine. It's fine. I was cautious, so I wanted to raid into you, and then I saw your title, and I was like, should we raid into this? I'm not sure. Maybe this is not right. But you know what? It's fine. My community are adults anyway. Most of them. Even though I teach science, my kind of reprographic? No. Demographic? Yeah, my demographic are adults who are interested in revising or just curious to try new things. So, there we go. That reminds me, 3 more days till I sign back on. 3 more days to back on? What do you mean sign back on? You don't know me. Okay, I'm sorry. I'm sorry, old bones. Although with the username of These Old Bones, I wonder if you are not an adult. Oh, picking modules for next term. Okay, fair enough, fair enough. The board, 2 seconds. I'll just grab my spray bottle. Sorry, I just lost my spray bottle. Lovely notes. Did you appreciate that all my H's were red and all my C's were blue? I put extra effort into this whiteboard. Do you do IRL classes? Yes, I'm a lecturer full-time. So that's why I only stream part-time. So all of this stuff I lecture in front of 200 students at a time sometimes. Well, not this stuff actually. I only teach general physics. The big rooms. What I'm about to teach now is what I teach physics students. A little bit of semiconductor, solid state, circuits, integrated circuits, chips, latches, and all the good stuff in between. No, not usually, but I don't think, like, if someone just snuck in and sat into the class, the big lecture rooms, no one would notice, I think. But you'd be spotted definitely in the smaller classes. I took a break, but I'm getting back gently. That's really awesome to hear, though. Have you selected? Have you chosen wisely or chosen poorly? Your subjects, Abendriel? Private? Bit of experimentation in physics and space, nice. The blue color was very close to the back, fair enough. Are you allowed to bring food in the classrooms? My general rule of thumb is that I don't comment if someone brings food, as long as it's not like, I don't know, a roast. You know, if they're sneakily eating M&Ms, I'm not going to say anything, you know? Can't do it obviously in the lab. Health and safety, you can't do that in the lab. But yeah, no. If you're eating M&Ms, I absolutely do not mind that. Don't plug it exactly. As long as you're not like crunching something really loudly and yeah, sardines. Weekend streaking, 45 stream streak. Let's go. So yes, bring your bacon grill. Super messy tortillas. So as long as you don't bring in that, I don't mind. To be honest, generally speaking, I don't really care what you guys do. Not you guys, but I don't really care what my students do. As long as they're not disrupting me, their classmates. Do whatever you want. If you want to sleep through my class, that's fine. Why are you there? If you are going to. So I'm only teaching for the sake of people learning. And number one and number two, passing the exam, of course. All right, I'll stick to coffee and croissant then. Fair enough, Liz, fair enough. All right, we'll do a bit of revision of gates. I think I will make one board, a whole bunch of gates. And yeah, I have a few gates. Let me see. We'll only do 4 gates because I have an and, nor, not. Sorry, I have an and, nor, not, and. So using those 4 gates, let's see what we can do. So a bit of revision, what an and gate is. And gate, the shape of it, like this. It can have more than one input. It can have 3 inputs if you want. Matter. Like. In terms of your truth table, the symbol is dot between them. We have A going in, that B and C. So if your truth table is A, X, 0, 0, 1, your output's going to be 0, 0, 1. Because ultimately, what your output is that you're multiplying those out. 0 by 0 is going to be 0, 0 by 1 is going to be 0, 1 by 0 is going to be 0, and 1 by 1 is going to be 1. So you're only going to get a high when your 2 inputs are high. And again, you can have a 9-line truth table, but they'll all be zeros other than the bottom line, pretty much. Okay, next thing. I have a, well, NAND gate, I suppose, the next one to kind of do following on from that. A NAND gate is very similar in shape, except we're going to put a little circle at the end. That's a general rule of thumb for these guys, because that means that we're just going to invert these guys, all their outputs. So that's A. How would I do that? Would that be A bar over them like that? I will just list the B so it looks separate. So if we had 0, 0, 0, 1, 1, 0, 1, 1. So then the output would be, we multiply them as normal. 0, 0 should be 0, but because we have a bar on the outcome, flip it over. That'll be 1. 0, 1 would be 0, the bar on top, flip it over, 1. 1 times 0 is going to be 0, a bar, flip it over, 1. 1 times a 1 is 1, there's a bar on it, flip it, 1, 1, 1. It's the exact opposite of an AND gate, hence NAND gate. Exactly, exactly. So you can either just know what an AND gate is and flip them, or you do the maths. Whichever way you prefer. Obviously, I would have initially learned them off, but then you learn that, oh, well, it's actually handy to learn them. An OR gate, slightly different in shape. It's like this. And the symbol for it is a plus. That's 0 plus 0. If you add 2 zeros together, you get a 0. 0 plus 1. That's a 1. 1 plus 0 is a 1. Chat. The billion-dollar question. What is 1 plus 1? Dun, 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 dun. plus 1 equal to... You would think 2. Maybe some of you, I see, thought it was 0 because they'll be the next one converted. But 1 or 1 is equal to 1. Nuh-uh. There we go. We have an OR gate. Now, you can imagine what a NOR gate is. It's then, we put an end sign here. We put this guy as a circle. And then we have 0, 1, then we would have 1, 0, 0, 0. We just flip all the outcomes pretty much. What other gate do I have? A NAND, or oh, a NOT gate. NOT gate. I think I know what it is. It's the triangle, right? It's the inverter. Am I right in saying that a NOT gate? Or I spread rumors. Okay. So then we have obviously the classical inverter, where we have a triangle symbol, dot, which means that if you have a 1 coming in, your output is going to be 0. If you have a 0 going in, your output is going to be... A NOR gate. I know, we have too many Australian friends. We can't be making fun of them, surely. Down for a little while. But those lab rats and labradoodles are all our logic gates that we're going to use. So today I have 2 NAND, 2 NOR, 2 NOT, and 2 AND. Well, in each chip, there's about 4 gates anyway to use, so we don't need too many. And yeah, we're going to build some logic circuits and combinations. And yeah, we're going to see what we're going to do. Are you going to show like a straight... Exactly. Well, I'm going to build a contraption. And then I'm going to get you to do the maths first and make a prediction if our output is going to be high or low. So that's going to be the plan. So let me think about output again. Yes, we can have an LED on the output for sure. What is Tofu's IQ? Tofu's IQ is 80. When I first did an IQ test online, I fell for a scam and it emailed me that my IQ was 80. A year later, I did do a proper IQ test out of curiosity. But chat has never let me down the 80 IQ. Math on a Sunday? I can't. No. It's not 80. No. I think it was 121 when we repeated it on stream. But again, it's not fair to say my IQ is 121. It could be higher, it could be lower, because I did it on stream and I was chatting, and I guess some of them I was getting really stuck in some of them, so I guess is not right, I think. I don't think you're supposed to guess, but anyways. I was hoping to do that, Ilgaz. That's the project over summer. I want to build a simple calculator out of logic gates. I might Ben Eater it, you know? There's a few projects over the summer. I need to upgrade my speed of sound experiments with a Mach 2. That might be one of the first projects I do. And the second project I want to do is I want to learn how to use a CNC. And again, I always need a project, and I checked like a few run sheets first before I legally can do this on stream. I'm actually going to build a vanadium battery on stream this summer. That's the plan. We're going to look at designs, constructions, materials, order the parts, and I'm going to drill them all, build them all on my CNC. That's the plan. If you guys are interested in seeing, it's like I need to start building my research group. With Domino's? No. Oh, I think I know. Yes, no, I have seen it, yes. Which gate uses the most transistors? NAND? They're all very similar. I think they need... Let me look at a TTL thing again. If I remember correctly... The difference between... No, Okay, that's not what I wanted. Let me look at my own lecture notes. Resistors, logic gate. So I have a lecture 5 here. Can't show, obviously, my lecture notes. West reason. But just to put it in perspective, an inverter, this gate, has 1, 2, 3, 4 transistors. And then a NAND gate has 1, 2, 3, 4. So yeah, you would think that this would be the easiest one. And technically you can build an inverter out of 1 gate, but you usually build it out of 4 because of noise immunity issues. You can use NAND and what's the other one? That's the other universal gate. NAND and something else. Exactly, that's what it is, Blue Charm. Inverter is exactly same as a NAND gate, but the 2 inputs are tied together. Exactly. It's interesting that you say that because I teach it the opposite way. I teach an inverter first, and then I teach how you can control by splitting 2 inputs, basically. Nor is just the opposite of this guy. Oh, as in the TTL. I don't know what the TTL of a NOR is. I haven't seen one. Oh, we might have to take a quick break here. There is a conversion using De Morgan's theorems. That's right. Good old De Morgan. I always call it chop the bar and change the sign. That's De Morgan's theorem. I know it sounds weird, but it makes sense. If anyone knows the theorem, my handy pickup line thing. Yeah. Alright, so what I might do is I might make a cup of tea. We'll make a cup of tea. We'll come back and we're going to design a circuit. Using NAND, NOR, NOTs, and ANDs. I'm going to tie them all together. And I'm going to ask chat then to solve it, and we're going to see if it's true. Hi, Hal. Welcome in, welcome in. Getting pop quizzes. I should do a pop quiz at the end of every stream. Come up with 3 questions that happened during the stream and test chat on them. Yeah, not that bright. I've seen a few of them. I'm not a big puzzle person, puzzle game person. I don't enjoy puzzle games. I get really frustrated and angry at them. I lose my temper a lot. Yeah, not very good. I'm gonna go pee. We'll be back in a little while, chat. I'll see you guys. Get up, drink, do some jumping jacks. Grab a cup. There you go, Ghost in Space Preserve! Welcome in, welcome in. Grab a cup of tea, and when we come back, we'll build a circuit and we'll do some testing.
And they call
Max,
it a
thank you so much for gifting a gift sub to Dark Shadow. Dark Shadow, enjoy Jay's emotes. He's a wonderful artist. You think so, Mac? I don't think it's hydration. It's just because I drank coffee and I'm dehydrated. And when you talk a lot, you do need to drink water anyway. Basically, I can't shut the fuck up, so that's why I drink water. Alright guys, I'll see you in a bit. And thank you again, Max. You're very, very kind for giving a gift sub to this community. You're very, very good. Thank you. Projectile motion is basically when an object is following a parabolic or curved path. And the reason it does this, usually in all of these examples, is because gravity is a very, very rude thing. Before Newton discovered gravity, we were all having so much fun. Jokes aside. The thing that makes projectile motion slightly awkward than normal kinematics that you might have encountered is the fact that things happen at angles. And basically what we have to do now is decipher these angles into X and Y components, horizontal and vertical. The description of the scene of The Lord of the Rings is basically Aragorn tossing Gimli across. We don't tell the elf. And there's a massive gap that he has to get across, but also the gap or the layer where the orcs are is slightly lower level. So there's a few approximations we have to make. Our goal here is to calculate how far across Gimli got yeeted, but also how long he was in the air. The first thing we estimate is the speed that Gimli is at, and we did a couple of things on my live Twitch stream to calculate this. Some of the things included calculating frames per second. Others did estimation of distance traveled per second, but basically we came up with 4 meters per second. The angle at which he was yeeted looked roughly 45-degree angle, and this is a chef's kiss of an angle to choose because this is the ideal angle to throw something usually. In this example, Gimli is being tossed at 4 meters per second and at an angle of 45 degrees. There is, however, also the issue that the level where Gimli is at and where the orcs are, there's a bit of a gap. And looking at the video over and over again, and again, estimations and conversations via my Twitch chat, we confirmed and believe that it was roughly 1 Gimli. This is a standard unit of measurement, and you cannot argue against me on this. 1 Gimli is roughly 1.37 meters, and so we estimate that the difference in height is about 1.37 meters in the vertical axis. As Gimli is being thrown, he follows a parabolic path, i.e. a curved path of motion. Basically, because we ignore air resistance, we say that the horizontal path remains constant. Nothing is changing the horizontal component of his speed at any point in time. We physicists love ignoring air resistance. But the y direction, the vertical component, changes every millisecond. At every point in time that Gimli is in the air, gravity is acting against Gimli, and at some point, at the highest peak, he wouldn't even be moving in the y direction. And then we'll begin to accelerate downwards. The vertical velocity changes at every moment in time. Here are some of the classical equations from kinematics that you would usually use to solve these problems. However, again, the problem here is linear motion. At the moment, we're at an angle and we're not exactly at linear motion, but we will decipher this. We have to break down Gimli's projectile motion into its x and y components. So, I hope you remember your trigonometry. If Gimli is being thrown at 4 meters per second at an angle of 45, we can depict the x and y component basically by using Pythagoras' theorem. Remembering your sine, cos, and tan rules, we can determine the speed of Gimli at the moment that he gets thrown in the x direction and the y direction. Remembering that opposite over hypotenuse is equal to sine 45, you can rearrange the equation to determine what the line of the opposite side is, i.e. his speed in the y direction. The answer is 2.83 meters per second in the y-axis. We can do the exact same thing except using cosine rule, adjacent over hypotenuse is equal to cos 45, and determine as well that the answer is 2.83 meters per second. What is going on? Why is the answer the same? Is this a mistake? No, this is what 45-degree angle is all about. So if you ever see that 45-degree angle, know that your components are going to be the same in the end. This is great. We just determined at what speed Gimli is going up initially and at what speed he's going sideways initially as 2 separate components. The first part we're going to determine is how long was Gimli in the air? And we have 3 kinematic equations we talked about earlier. You could sit there and basically decipher, tick off what information you have and what information you're looking for. And using this method, you can determine that you need the s is equal to ut plus a half of at squared. The x naught cancels off because that's the initial position and the initial position is 0. What we're doing here is we're substituting all the y components. How long Gimli is in the air is only dependent on the y vector, all the up arrows and all the down arrows, and that's what we're substituting here in this equation. We determined that roughly the height difference was 1.37 meters, 1 Gimli, but remember it has to be a negative. And also remember that when substituting for gravity, you have to make it minus 9.81 meters per second squared, because gravity is acting against us. We then get ourselves into a quadratic equation and we use the minus b formula. We know what the a component, b component, and c component is. I simplified the mathematics here and subbed in all the values, but we get 2 possible answers because there's a plus or minus part of the equation. Okay, welcome back. Thank you, thank you. I'm going to assign a bit of homework to y'all. Bit of homework. Okay, so if anyone wants to solve this, they can. You can write the answer down for yourself if you're interested in testing your knowledge. But what I'm going to do is I'm going to just build a random circuit on the board. And then I am going to just let it hang. And we're going to build the circuit and we're going to test if it's true or not and see if your logic works out. And I'll show you the mathematical way of solving it. Keep track of your ones and zeros. Here we go. So, what gates do I have? I have a NAND gate. Okay. So, and there's a cat. 2 seconds. I'm distracted. Ethan cut down a tree today. Cat underneath the tree, and it's laying there. That's a Where do you see a penis? Goodness me, chat. Despicable. Despicable. Ugh! Oh, I have a NAND. So if I have high, low, 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 what is the outcome? There we go. I see grown-ups made it to the chat. So this is the circuit I'm going to build. Obviously, you can do your quick mental maths and check it. We'll do the maths afterwards. But for now, let's build a circuit and let's see how these logic gates operate. I'll just move this a little bit back. I'll grab some stuff. I'll grab a power supply. There we go. I will grab some wires and LEDs. Oh, I have LEDs here. Okay, tap down. Uppies, uppy piggies. What I might do is I might bring me here as well so that you guys can see a bit better. Oh, really should make a lot more room on my desk. Very, very klutzy. Klutzy or clumsy, whichever one I use. Marker over here. Mat over here. Go. Put that here. Here we go. Shove over. All right. Cool. Move the camera a little bit this way. We'll zoom in a bit more. Excellent. So we'll build everything here. Oh, breadboard, breadboard, breadboard. Ah. Nice. So here we have a breadboard. Quick revision. All of these lines are connected with one another. All of these lines are connected with one another. There seems to be a misconception, by the way. A lot of people think that the plus thing is positive, port, and the negative line is negative. And you might be saying, Tofu, yeah, that's what those mean. And I'm like, yes, that's what those signs mean. But there's nothing inherently different about those connections. This is just one single line connected. So if you have a very complex circuit, you can actually utilize these lines for other reasons. So just be wary that that's a thing. A lot of people seem to, you know, be worried about them in other ways. Just telling you, no need to be worried. All is good. All is good. Hi, Risto. Welcome in. Welcome in. My mouse is over here. I'll put it here. Still use it a little bit. Sure, my Skyrim music is playing in the background. A nice study ambiance. Okay. Now, the thing about these circuits is that we actually need to operate all of them. So the first one is a NAND. This guy here is a NAND. And I'll show you what the chips look like so that you guys are aware. Let me zoom in. Here we go. So if you look at the data sheet, there's a little semicircle here. And that shows you, this is, if you put it in this orientation, there is V out. There is ground, or sorry, V in. There is ground. And these are what all the different numbers represent. So if you're wondering, like, how does she know which way is up or which way is down? If you look at a chip carefully, you'll see that there's a little chip on the chip. And that's the orientation that we're going to choose for it. Those are SN 7400 chips. A classic, one would say. Like this. Nice. I'll keep the box here to myself. What's really nice about them as well is that you can fit them in nicely like that as well. They fit perfectly in the middle of a breadboard. Hi, Omia. Welcome in. Welcome in. Welcome from Brazil. That chip has a chip on its shoulder. What I was highlighting on Stable D is that there isn't inherently anything different about those lines connected. Yes, there's just the positive sign, negative sign, but you can use it with whatever way you want. Sure, you'd stick to the notation, but there is sometimes a misconception amongst young, fresh students that these are specially designed positive and negative lines. Just highlighting that they're not. Not much different. Not much different at all. Will I stick to ground? I might stick all of these guys negative and these guys to ground. Okay. So a thing that we need to be aware about how TTL works is that actually this would have made sense if I made the structure of a TTL for you, chat. But just to be aware that we actually have to power the chip. One of the really cool things is if you look at it at transistors, you'll see that you need a transistor to be always on. There's the first transistor, which is the steering current, you know? It's going to actually steer which way the current is going to go on and off and go into the next transistor and go on and so forth. So it turns on other transistors while it turns off other transistors. So there's going to be a very important aspect inside that we just need to baseline turn on. I'm going to use this guy so that I can pull it out carefully. I have long nails, unfortunately, these days. I'm just going to move it down a bit. It is really satisfying, though, that the chips go in straight in like this. I'll zoom in a little bit more. Oh, so satisfying. So do be careful. I do recommend using these guys versus your nails, just because when you're pulling it out by hand, you'll be tempted to pull it at this edge here. And so one part of the pin will be lifted up while the other parts are going to be embedded. They're going to be bent at an angle and you're going to damage those pins over time. So I highly recommend using, not tweezers, pliers. These little pliers. And so when you pull these guys out, you pull them straight up wherever you can. Just a good way, good practice to avoid damaging the pins. Okay. Also, my thing is upside down. Doesn't matter. Chip pullers are a thing. Oh, really? I didn't know that. I just use pliers. Are they just like pliers? Okay, so we're going to connect all of this to the power supply here. How do I know that that's the power supply? Well, I have a little data sheet in here and it says VCC. I'm going to connect that guy in there. Need to avoid connecting the different pins together unless you want that. Being across the middle, it does, exactly. Because you can't short all the pins together. That'll be very bad. I'm trying to understand. Do I want to go here in this pin? I'm wondering though about the screwdriver, Willie, that I think they're... Do you not bend at one side like I had mentioned earlier there, that there could be a problem? Or are you just very, very careful? Then the pin here at the bottom, I'm actually going to zoom in a little bit more. There we go, so we can see a lot more. The pin at the bottom here is ground. So once this guy is connected, we have power this. Nice. I want to stick to the color convention, but I don't think it's going to work out. I don't have the right wires. That's okay. There we go. Okay, so we've ground. So we've powered and we've ground. Now that it's working, oh, I'll check this out, Mob Farmer. I want to see what it looks like. I've never seen those guys. Oh, page not found. I didn't get a page link, sorry. Oh well. Okay, so what we can do is we can control input 1 and input 2. I'm just going to use red wires, or I'm going to try and color code this for myself. If it's meant to be a high, I'll use a red wire based on our circuit. And if it's a ground, I'll use a gray wire based on our circuit. So there we go. Ta-da! Input A, input B, and that's done. So what is our output? It's the next chip down. So usually chip 1, chip 2, the third chip after that is the input of our next chip. So I'm looking at the board behind me. I have a drawing of the circuit behind me. Do you guys see this clearly? I can increase the brightness of the stream in case needed. Oh, and that goes into the last one. So we'll leave that guy go. The next guy we need is a NOR gate. So my NOR gate is this one, my SN74LS02N. This is the version 2, thank you. Let me check that out. Oh, it's kind of nice. That's a really handy tool. If we're going to build that, if we're going to mess around with so many logic gates, maybe that's a good idea to buy that guy. That is a handy thing, I can see why. I'm gonna down here because that's going to be the output of a AND gate. I'm going to put an AND gate here just because it's going to be neater. This is our final gate. I'm putting the final gate early. And as you can see, some of the legs are bent, so I'm just going to try and fix that very gently. Someone pulled this out very badly last time, and you can see that they're bent in a very, very specific way. If you're trying to fix them, you kind of hover over the board first. See that they pin down, and then apply pressure. Should clip in nice. Very good, very good. I use them a lot when computers use chips to upgrade RAM. Oh yeah, that's class. Jesus, those were the good old days. That was way before my time even. Okay. So that is the NAND. This is the AND, and then this is the NOR. We're going to put a NOR gate in here. Do 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 do. Do 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 do. Generally speaking, most of them have very similar chip layout. So if I'm looking at the NOR, the VCC is in the exact same position, and so is the ground. Very rare that the chips are all over the place. Oh, except for this one. She jinxed herself. Said it was going to be the same, and already is not. Bum, bum, ba-da-bum, bum, bum, bum. Bum, bum, ba-da-da-dum, dum, da-da-dum, dum, dum, dum. I have not watched Jurassic Park in a very long time. I have no idea why I think of Jurassic Park when I'm doing this. Okay, so we've powered our NOR, and in this guy, the output is actually the first pin, so that's unusual. You might, yeah, so that's interesting. And then the input is the next two. So these are the two that we're controlling, and I'm looking at the board, and I said, what if those two guys were low, low? Okay, so if these guys were, so first pin is the output, second pin is, bastard. The dancing dinosaur to the Jurassic Park theme song. So both of these guys are low. So I've colored them in, or I've used grey wires to kind of show that we're going to ground them. In case you're wondering, because again, I didn't actually mention this since we didn't do a proper lesson on this. When I say high or low, it means high voltage output or low voltage output. Because when we talk about digital signals, we usually say there is a signal coming in or there isn't. There is a concept of noise immunity and all these little things that we need to be wary of. But generally speaking, we do not use those guys. Okay, last one I need is a NOT gate, which is this guy here. Might use a shorter wire to get it across. So remember, a NOT gate is just an inverter. Basically, if we are getting an input of high, our output will be low, or if our input is low, our output is high. And obviously, don't forget to power every single chip. They all need the 5 volts. Not. Ba-da-bum. Bum, bum, bum. So I'm going to power this one. This. Infinite power! Jeez, I'm so scared about making a joke about infinite power ever since I got traumatized on the internet for making a joke about having infinite power with wind turbines. I'll never live it down, chat. I'll never live it down. I'm going to be known as the person who did a PhD in electric grid stability, in wind turbines and battery technology, who didn't know that wind turbines does not mean infinite power. That is what I'm going to go down for in history. There we go. How do I hook up 2k volt to 20 amp? What do you mean? What are you doing? Why do you need so much? So I'm going to look at the data sheet here for it, and it says that it's just a input here. The next guy is the output. So we're almost done. Almost done. So I'm looking at the AND gate here. The AND gate is the two inputs here. So I've inputted the last guy in there. That's terrible words. You're trying to keep track of it. It's like, what the hell did she just say? Dang. So it's hard because I need to show you the circuit diagram on the board. But oh, my wires are all together. So the output of this guy is the input of the last gate, which is the AND gate. So we have two inputs here, one from this gate, one from this gate, which is from this gate originally. There we go. And so we have two inputs into our AND. And our output will be another wire over here. And I'm going to move it all the way to the bottom of the breadboard. And the reason I'm moving it all the way to the bottom of the breadboard is because, well, a lot of these circuits are shorted. So I need to go into an area where I have no chips at the moment. So we need to get a LED then. Here we go. A red LED would work perfect. Do I need a current limiting resistor on the output? Usually the current that comes out of these guys is very, very small, but I might just, for argument's sake, put it in. Here we go. Better safe than sorry. And then connect it to ground. All a common ground. Okay. Now, if the thing is meant to be off, if the answer is low, we do have a bit of an issue because it's like, well, how do we know this is working? So that's a fair question. Perhaps we should test this if this works by confirming ourselves that there is a high, if that makes sense. As in, let's look at the circuit and just see what do we need to do to get an output of high. So let's look at our circuit really. I'm going to do some mental maths really quick. So that's a NAND. I want the okay, we can keep that there. That stays the same. This is an okay, so I just changed that input to be high, and that should change then. Okay. Oh, sorry, I dropped my camera. My bad. Sorry. Sorry, chat. Handling you so poorly. Okay, so as long as I change these two guys to high, our outcome should be high. Also, I didn't power the last chip. Completely forgot about that. Whoopsie daisies. We don't want Twitch claim that we purposely release magic smoke. Exactly. I don't need that kind of reputation. I have been blue smokeless all my life. I want to keep it that way. Cool. So I'm just going to turn on the power supply. So according to this circuit that I've just really tested, we're just going to test if it's meant to be a high. Oh, I need to plug it in. Chat, if I suddenly disconnect, don't panic. Just the internet's being the internet. Not worried. Whew. Oh. Okay. So we're gonna set the voltage to... PCV. What's going on with my power supply? Okay, there we go. That was odd. Okay, so we're just going to set it to 22 to 5 volts, 22 volts. Gyre, thank you so much for the raid. Welcome in, raiders. Chat, do not panic. We're getting raided.
Red alert. All hands stand to battle stations. Laying an intercept course on the Romulan ship.
Shields up, load all torpedo bays. Stand by phasers.
Warp factor 8. Engage.
Welcome in, raiders. You're playing Expedition 33. Oh, I hope you're having a blast and a half. That game is so good. Such a fantastic and wonderful gem. I hope you're enjoying it. 22 volts on a TT. Yeah. 22 volts, and you're definitely asking for a fire alarm for sure. Woo. Drop the voltage a bit. Okay. 4.97 volts. Close enough. I'll turn that off because this thing gives me spark sometimes. I'll just short this at the current limit just to protect our TTLs and everything. So we shouldn't need... Oh my god, it's at fucking 3 amps. Jesus Christ. Milliamps is more than enough. 40 milliamps is more than enough. But I need to sleep now. No worries. Thank you so much for raiding your community over here. We'll take care of them. We promise that in their first round, they will not be used in experiments. Maybe the second or third. Thank you so much for sending your community over here. Appreciate it. All right, ladies and gentlemen, lab rats, labradoodles, and everything in between. If this works, this should light up red. Let's go. Bomb, 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 bada bomb. And Tofu said, "Let there be light." Our logic circuit works. Booyah, booyah, booyah. Anyways, where was I? So. It looks like a lot of effort to light an LED. That's not the point of the circuit. Anyways, what I was going to say though is that's not our circuit though. Our circuit actually said, what if this gate, the, what was the first one? It was a NAND and a NOR. The NOR had to have 2 negatives. So let's see what happens if we do that. Da, da, da. There we go. Here we go, chat. We get a low output. Many of you guys predicted in the chat that it was going to be low. I think many of you guys did guess it. But that is correct. When we build the logic gate from the whiteboard with this guy as 2 lows, we get a high output. Woo! Look at that go. If I change this guy. Oh no, that's actually hard to do. What if I change this guy to low, low? Stays high. Cool. Guess? Psh. I mean, you had a 50-50 chance. You had a 50-50 chance. All right. Now, we'll go back to the drawing board. It was applied knowledge. Look at the whiteboard. Okay, so. This is a NAND gate. So think of an AND 1 multiplied by 0 is equal to 0, but it's an inverter, which means we inverted. Our output has to be high, and so we have a 1 going in. Whoops. This must be high then. Next, this is an OR, the plus sign, but it's an OR. We'll wait to that. 0 plus 0 is 0, but it's an inverter at the end. We flip it over because it's an OR gate. That's a high. A high going into an inverter, which means we just flip it into 0. High is 0. This is the final boss, the AND gate. 1 times 0 is going to be 0. Our output is below. And that's exactly what we got in the logic circuit that we built. So we know we number one, mathematically proved it, but also conceptually proved it. So well done. Is it really 50-50 chance if we could have set the circuit on fire, turning the device to a flaming lamp? Why would you make the device a flaming lamp? What are we trying to achieve here? Can we let some smoke out? No. And you're going in the bold corner for even suggesting it. Bad for Zerp. Bad for Zerp. Ugh, there we go. 3 amps. I mean, if there was 3 amps, Jesus, I don't even get 3 amps in my battery research. I think 2 amps is the maximum we really work with. All right, let's clean up a few bits and pieces. I'm looking forward to building the battery during the summer. All these projects and all these things I'm promising over the summer, and time is going to fly. Yeah. We'll see. You never know. Maybe my love for science and physics is going to die one day. For now, while I'm passionate, while I'm in love, I'll just keep doing what I love. So many people are, giving a heads up that, your Lenore, I think. Your love for physics and science is going to die out. Your passion for learning. Someone said the age of 33 is where our brain's curiosity begins to steeply decline. Until then, we gotta make the best out of our love and our passion. CMOS logic. Well, as in yes, you can make TTL, you can make logic gates out of CMOS, yes. MOSFETs, absolutely. As in make a logic gate yourself. Is that what you're saying? Damn, no one told my brain that. There was a weird study done about something about our brain's capability of learning. Our peak performance is somewhere 33 years old. Study recently talked about. What is the difference between acceleration and velocity? Zen, welcome in. So, the hint is in the unit, if that helps. The unit for velocity is meters per second. It's speed. It's just speed with a given direction. Don't worry about that part. It's just speed. So when you're driving in your car, you see the signs and they say 30 kilometers per hour. That's the speed limit. Distance over time. Meters per second is the SI unit for it. Acceleration is when you're speeding up or slowing down. So it's putting your foot on the brake or on the pedal. And it's the rate at which speed changes per unit time. So it's meters per second. So that's where you get meters per second squared. It's how quickly your speed is changing. I don't know if that helps. Because another definition for acceleration is you're still moving the same velocity, but you're changing direction at any given moment. But a general kind of overview for there would be nice way to start it there is that acceleration and velocity, the hint is in the unit. Velocity is meters per second, distance per unit time, what we commonly know in the English language as speed. And then acceleration is how quickly that speed changes. Yes, but that is peak output, not input. Don't believe them, says Arwell. Well, look. People are saying that, you know, we will lose interest in science, we'll lose interest in learning. You never know. Wow, that's pretty damn fast if I do say so myself, Ken. And I guess my pessimistic thing about learning comes from the fact that I observe so many lecturers of physics. I see the young physics lecturers really love physics. They really adore it and they're so good at teaching. But because they're young in their career, they're not given the same opportunities as older lecturers, which is fair enough. But then the older lecturers, because they've been teaching for so long and so much, they seem to have lost the passion for teaching, or, you know, being enthusiastic about the stuff that they do. But they get priority on what modules and what subjects they teach. And yeah, it's a vicious, I think that's just a cycle of life, you know, of any kind of institution of any sorts has that, with new blood coming in, new ideas, new passions, new whatever. That's true, Zier. That's true. All I need is a couple of reviewer twos to knock me off my pedestal, and I'll be a grumpy tofu. I just pinched myself. Ouch. Yeah, I agree, Conrad. So I would think it would be important for the mentality of teachers, lecturers, to switch subjects every now and then. I got bunked. Ooh, I did pinch myself quite badly there. Grump fu? Yes, a grumpy tofu. Could that just be due to the repetition and the passion? Exactly. Well, I think it's a good idea to force lecturers to switch their subject every like 5 years or something. But I know a lot of lecturers aren't happy about that because that means re-preparing material. So some people don't want that. They want to teach the same thing because you teach the same material over and over again. Here's the thing. I'm going to be honest with you. After being a fresh new teacher for a whole year and then going into second year and repeating the module, I actually have had a life this semester. For the first time since I've become a lecturer, I didn't have to prepare any material, even though I still did. I innovated new material. I still updated things. I put in effort again. But it is important to highlight that I didn't have a new module to learn, to make lecture notes, to examine, and to teach and write a descriptor and everything. I've been able to come home every day this year, almost every day. There might have been 2 or 3 days, but every day this semester, and not work every evening. So it is a huge workload if you're teaching a new subject, because you have to stay up late every evening. You're preparing lecture notes. You're staying ahead of the students a little bit where you can, but that's the Exactly, Helen. That's why I feel like general physics is really fun to teach because of that. Because the type of students that you teach are different every year. So some are going to be very nerdy, some aren't. Some are going to be into video games while other people are going to be into sports. And so you're just your teaching style to try and cater for them. So I think general physics will never get bored in that sense. Hello, ma'am. Hello, Cheetan. Welcome in, welcome in. Although, like we mentioned, the iPad babies are coming next year. Can't believe already. The next generation is here. The iPad babies are coming. They're coming for us all! How time flies. How time flies. Over here. Uh. Listen, if they can use their laptops, I'd be happy. I'd be happy. That's true. Computer science would update all the time. You're right. That's true. Physics is so embedded, especially like even classical and modern. Like yeah, it's so embedded that we don't have to change the course. But computer science has to be updated quite often. That makes sense. Such is life. Such is life. Although it might be cyclical and the Lord of the Ring memes become relevant again. Perhaps. Yeah, I need to stop referencing Predator, Alien, and Lord of the Rings in my physics lectures because it started like 4 years ago where I noticed people didn't get the reference and I was like, what do you mean? Have you not seen Alien before? And they're like, no, don't know what that is. Then I'm trying to show their infrared camera. They're like, yeah, no, I don't know what Predator is. And so I talk about the joke of tossing Gimli and we're trying to calculate Gimli's projectile motion. And they're like, no, we haven't seen Lord of the Rings. So I need to learn new things that are relevant to the young populace, the young generation. There was some 6-7 thing going on for a while. There was a toilet. Skidding toilet. That was a thing for a while. Do I need to learn that? Is that something I need to learn? I need to develop a new language for science, for the kids. You can give them assignments. Yeah, I told them over the midterm break, make sure to watch. I always tell them. So anytime students say, no, we've never seen Lord of the Rings, I tell them, make sure over the midterm you watch Lord of the Rings. Yeah. What can we say? What can we say? Time moves. Time moves on and we're getting left behind, chat. We're getting older. Probably none the wiser. Oh, most of these kids don't play games, Shark. The computer science students would, but not the kids that I teach, really. Only a handful, which is fine. I still teach them. I teach them about CPU cooling, why there's such a large surface area, why is it made out of the metal that it's made out of. I do try to make it as relevant as possible for sure, but yeah. That's true. Memes don't last very long. You have to stay updated with them. That is also true. Let me put away my resistors into my resistor box. Okay. All 3 movies in the same day is the only way to watch The Lord of the Rings. Oh, my nose is itchy. Although there are recent films from Predator and the Alien universes, I've heard of them, yeah. I haven't seen any of them. To be honest, I don't think I've seen any Predator movie outside of Predator 1. Maybe I've seen the second one, but I don't remember it. I think it was shit. If I don't remember it, it's clearly terrible. No, I don't really remember those movies, unfortunately, so yeah, I'm not sure. Have you seen the B movie? No. No, I have not. Next, you have students how to draw circuits Where the transistors are smaller than X-rays. Yeah, at some point... I know that teaching basics is really, really important for students. Because if you have the foundations to figure out how all of these work, you understand the foundations of everything else that works. But I also understand this element of, well, a degree is 4 years and you can only do 5 to 7 subjects a semester. And there's a placement and there's all of this and there's all of that. And you have to wonder at some point, do some subjects become a little bit more redundant than others? That with time, it would be so much more beneficial for the students to learn a more advanced module. Not advanced in difficulty, but advanced in technology. But it's always heartbreaking that the fundamentals don't get covered then. Because I see it right now. I see it with certain tech spheres that they're dropping the subjects. Introduction to physics, basic electronics, DC fundamentals, you know, all of these things. Because they're like, look, we need to cover C, D, E, and F because that's what's going to be in their jobs. And we have to give up all these beginner stuff. Alien Romulus. Yeah, I saw that in cinemas. I thought it was quite good. Nate didn't like it though. but that shouldn't mean anything. It's very rare to like a new movie. Both of us don't tend to like new movies generally anyway. It was okay, it was okay. Ooh, the tensile strength of the bow. That's a good one. Drop all the stuff that can be learned in their own time. I mean, anything can be learned, I suppose, in anyone's time. I suppose the worry I have is that when things go wrong, right? Let's say you learn more advanced modules, but it breaks. Because you don't have fundamental stuff covered, how do you troubleshoot the system? You know? I do worry that that's where the information is going to be dropped in their experience when they go through life. Ah, look, you know what? I can't be out there saying all these problems, saying, oh, there's a problem A, B, and C when I can't come up with a good solution. I don't have a solution. It's just what it is. It is what it is, you know, with the world. Moving on very, very quickly. Very, very quick. I don't think I've seen the Prey movie. Sadly, that was true of many fresh out of school new hires. Yeah, well, I suppose the other argument to hire fresh young blood is that you can mold them, you can train them. If you can train them into your specific needs and your specific troubleshooting and your specific stuff. Hard to know the solution for these problems. But as one says, it's above my pay grade, so we're not going to start. Nothing exactly. According to my brain, the way I'm rationalizing it at the moment, Bones, is that a 4-year degree has to become a 6-year degree now. And a 6-year, and then a master's needs to be an additional 2, and a PhD needs to become longer now. I don't know. I don't know what to do. I don't know what the solution is to the problem. I feel like there isn't really one there. What I might do is, we're just approaching the end of the hour there, is that we'll take a little break, and if you'll have me, we'll play some games. We'll play some Dyson Sphere program. If you guys are interested, my spaghetti is doing extremely well, thank you very much. I don't know how much more I have in me for Dyson Sphere. I kind of want to get to the Dyson Sphere part. Will you do a stream with Hannah Fry? If Hannah Fry ever finds me, if Hannah Fry ever recognizes me, hands down, I would do one. Yes. Would 6 years be about 600 hours? I don't know if you can correlate those two things because every person is going to be very, very different. What is counted as study time? Is it the note-taking, the lecture attendance, and then the personal study, the labs? You know, it's very, very hard to know for sure what we mean by study hours. That's why I don't really like curriculum outlines, because they'll mention how many hours they expect, and it's kind of like, well... Okay, I'm going to go pee. We're going to unlive YouTube. We're finished the science segment. And then we're going to play games. Exactly, Frizzer. We're going to play games. I have a feeling Tofu's never stopped. So yeah, absolutely. There has not been, I will say, a month that's gone by without me studying. Well, studying is a strong word. Again, what does study mean? Learning. Although you can argue that we're always learning. What I mean is like academic learning. I definitely have never stopped that. I've been in an educational institution all my life. From the moment I was 4 years old and I joined junior infants. It has just never stopped, chat. I think I'm trapped. I never see the sun. All right, see you in a bit. Video game. And being awfully addicting. It's also not an easy game. I hope you enjoy